Alright, hello everyone, and welcome to the first part of the POPX Soft Body series. In this series of tutorials, we're going to learn about creating soft body simulations. We're going to see how to construct a constraint using the constraint operators, and finally, how the soft body works and cover all of these functionalities. So, for this part, we're going to create a cloth simulation. So let's get started. For our cloth, I'm going to create a grid. So I'm going to drop a grid pop. Let's visualize it. And I'm going to change the connectivity to alternating triangles. This is much better to use triangles in the soft body solver. So for a typical cloth, we will need to construct two types of constraints. One is the distance constraint between the triangle edges, and the second one is a bend constraint between the tips of two adjacent triangles. So let's do that by dropping a constraint operator. The constraint operator takes a geometry and basically generate constraint for that geometry. And it also applies some properties for the geometry itself, like mass, thickness, drag forces. You can pin do animation and another functions over here that we will look at future tutorials. For the constraint, go to the constraint tab and you can choose which type of constraint you want. So for a cloth, we need a distance along edges and the bend across triangle constraint. So for cloth, basically you can just choose to generate cloth constraint, which will generate both of them together. But first, let's look at the distance along edges. So I'm going to connect my grid into the first input of the constraint. And I'm going to choose the distance along edge constraint. And I'm going to display this. And you can't really see much, but what is actually happening here is that the constraint operator generated for each triangle a line and its length and all the constraint properties, which are stiffness, damping ratio, the rest length, and you can also add some plasticity that we will look at future tutorials. Let's look at the bend across triangles constraint. These are looking a bit different because they are connecting lines between two adjacent triangles tips. If I choose the cloth constraint, this will generate both of them. Now you can play with the parameters over here for the stretch and bend. The stretch are for the distance constraints and the bend are for the bend constraints. So for example, if I choose to generate only the distance along edges, you will see that the bend parameters are disabled. Or if I choose only the bend across triangles, only the bend part of the parameters are enabled and the stretch are disabled. So when we generate cloth constraint, both of them are enabled because it's going to generate both distance and bend constraints. Now each group of constraint, you can play around with the stiffness, the damping ratio, the rest length, and as I said, you can add plasticity, and you can also define a group for that constraint. For now, let's leave all these parameters as their default. And what I want to do next is to create some pin to target constraint at the edges of the cloth to basically not allow him to drop down into infinity. Something just happened here. Let me reopen it. So for doing that, I'm going to create a group with a group up and connect my grid. And I'm going to name the group pinned. And let's enable the debug color. And I want to do it based on bounding box. So I'm going to enable this. And I'm going to scale it. And actually, let's display it in the geometry viewer. Going to scale it and translate it to the edge, to the left edge. Something like this, maybe. And I'm going to add another bounding box and enable it and paste the values. And make it to the right side. So now we have our group of points. Let's disable the debug color. And I can connect the group into the constraint. And I can choose now pin to target. For that, I need to reference the group that I just created. So if I don't see it over here, I can right click on the constraint operator and force cookie. And then I will see this. And now you can see that it colored our pinpoint with red color. So let's add another constraint after the pin to target constraint and connect the geometry to the geometry, the output of the constraint to the input of the second constraint so that they will be merged. And we also, by the way, have a third input and output, which is the collision geometry, which we won't use right now, and we will see it in future tutorials. So in the second constraint, I'm going to choose the cloth constraint. And now we have all the constraints that we need for this simulation. Now I'm going to drop the soft body solver, but before I'm going to connect a constraint config. So this is the last operator that you will drop between your constraint and the solver. And what it does, it's basically taking the constraint geometry from the second input over here. So here's our constraint, and it's basically transferring them into the points over here of the simulated geometry. So this is a crucial component that you must have before the soft body. So the soft body basically will know how to solve the constraints. So I'm going to connect the constraint and the simulated geometry. And important is to reference your solver over here on the soft body solver parameter on the constraint config. Now I can drop also a keyboard in to reset my simulation. And let's display the soft body. So the default here is that there is a ground collision, and I don't want ground collision right now, so I'm going to disable the collision. And I'm going to connect the geometry and the constraint, and we have our cloth. Now in the soft body simulation, on the post processing, I will disable the post smooth position. For cloth, typically this is something that you won't need, but for other geometries, for example, like a mesh that has pressure or struts volume constraint, this is a good feature for smoothing out the artifacts of the constraint solving. Now in the soft body here, you have your um, parameters, you can increase the constraint iteration or the substeps. This will make the solver solve much more accurate and fast. So, for example, if I increase the grid resolution over here, we will have more constraints. And you will see that the gloss will start going down because we are applying gravity here in the forces. You can increase a bit the iteration to make it uh, less soft. And also you can see that we have like kind of like a springy effect. So if you want less of this, you can increase the velocity damping over here. This is one option. Or you can go, for example, to the one of the constraints, and in the geometry page, you can increase the tangent drag. So it will have less jumpiness. Now I want to see the cloth a bit better. So I'm going to add some noise to it to deform it a bit. But I want to apply it only for the points that are not pinned. So I'm going to add another group pop and connect the first group pop. I'm going to say here noise, name the new group, and I'm going to take the pinned group and invert them. And I'm going to add a noise pop and choose here the group that I just created. And I'm going to decrease a bit the noise amplitude and maybe decrease the period of the noise. And I'm going to reset my simulation. So now we can, let me just toggle off the adapting home. We can see a bit better our cloth. And I can also on the output here compute the normals maybe for a better normals computation. And maybe increase a bit the noise. Decrease the period. Maybe it's too much of noise. Okay, I think this is good enough for us. Now, in this part, what I want to do is to interact with this cloth. So to do that, I can use the one of the forces over here, which is the last one, the grabber, which allows you to basically define a region where you can grab your soft body. For doing it the right way and basically see the effect much more, we need to basically create a simple render network to render this cloth. And then with the panel um, of our project, we can interact with the render using the panel chop. So first, let's actually create the render setup. I'm going to drop a render. I'm going to take and connect the null to my main output of the soft body and create a geometry. Let's add a camera and a light. And I'm going to change the render resolution to 1080 by 1080 and connect an output. And I'm going to go into the project parameters by right clicking on the path over here. And I'm going to change the layout width and height also to 1080 by 1080. And it was already set up, so we're good. And in the background top, I'm going to reference the output over here. just like that. It was also already set up. And here I'm going to the pane type and select the panel. And now I can see the rendered cloth. Now on my camera, I want it to be orthographic like this. And the ortho width, I want to make it 1, which is basically the ratio of our resolution. Now the cloth is covering the entire render screen. So what I want is to transform it and scale it a bit. So I'm going to create a transform and maybe scale it down a bit and reset my simulation. Maybe scale it even more. And let's translate it a bit up and maybe scale it on the x-axis like that. Okay, let me actually maybe increase more the grid resolution and reset the simulation and maybe increase more of the iterations over here and maybe a bit more of the substeps. Now in the render, let's create some shadows, because why not? And play around with the light. Maybe increase a bit the shadow resolution and create a nice material with the PBR material for our cloth. All right, so now let's um, enable the grabber on the forces tab. And what I want to do is I want to visualize it with a sphere on the render. So in the panel that I dropped before, it's automatically referencing the panel of the project. So I want to select the inside U and inside V and also the left select. So now you can see when I move around my panel, the U and the V are moving, and if I left click, it's going to toggle the left select over here. Now let's select only the U and V. And I want to create a sphere pop and make it grid and use rows and columns. Decrease the rows to 4. Maybe more, something like that. Maybe let's choose only columns. And I'm going to connect a gear for it. And after the select over here, I'm going to connect a null and reference on the geo to translate by the X and by the Y. So our sphere now is huge. So I'm going to basically scale it down. And as you can see, when I move, it's not really pointing at my mouse cursor. This is because we need to offset our U and V by half. So I'm going to create a math just before the null, and in the mult add, I'm going to pre-add minus 0.5. Let's maybe decrease more the radius, and I want to create a simple Fung material for the sphere, and maybe in the comment tab, choose the wireframe and increase it a bit so we can see it better. Maybe let's color it with a red color. And I don't want actually the sphere to cast shadows on the cloth. So in the shadows, I'm just going to delete the shadow caster. Now in our soft body solver here, I'm going to reference the same positions, but not the one that are inverted, sorry, that are offsetted by minus zero point 0.5, or actually maybe I do need to offset them. Let's check it out. And I'm going to reference the same radius from the sphere onto the radius of the grabber. And here I'm going to also visualize the grabber points. And okay, we're seeing that we're in the right position. So where I'm selecting uh, the cloth, I can see the red color. And now to actually grab, I need to push this grab toggle over here. And this I will reference the left select over here. And if I press, you can see that I can interact with the cloth, but it feels like it's too hard. So I can enable the transition range over here to make it a little bit softer, and maybe the transition align. Oh, this is too much. Yeah, maybe on the constraint where we defined it, the drag, keep it lower a bit, and maybe less iterations will make it a bit more springy. And here you go. We're interacting in real time with a cloth. So you will find the same project, an example inside the POPX release folder. So you can explore it also. It's practically the same example, but I wanted to explain how to make it. And while I'm explaining, to for you to learn what are these operators and what the purpose of each of one of them. In the next tutorials, we're going to look at more examples for more like soft body simulations and how to change the properties of the constraints over here while we're simulating with the constraint property operator. And yeah, this is it. Thank you for watching. I hope you enjoyed this tutorial, and I will see you in the next one. Bye bye. Thank you.